Welcome viewers. Today we are going to discuss a very important topic which is related to your course Kinematics and Dynamics of Mechanism, which is in third year of your BTech Mechanical in Computer Integrated Manufacturing. This course is designed basically to give you a basic idea about different types of mechanism involved in the different machineries. You always come across the different type of machines. For example, in your house, sewing machine, when you go to the office, scooter, car or cycle, all are using a simple type of simple or complex type of machine. Now, how this machine is based on which type of mechanism, this basically deals or dealt in this subject. So in this way, this is very interesting topic, because whatever theory, whatever aspect you are studying in this course, that is directly linked with the practical aspect. So once you are seeing that certain mechanism, just for example the rotation of the wheel, then you will always see in the cycle or in the sewing machine. So in this way, this topic is very interesting and useful. That is why that is kept in the third year, and this is also being taught in every engineering colleges for BTech Mechanical. So today we will take up the small issues in this, small definitions, simple definitions, and the basic concept regarding this kinematics and the dynamics of machines. So first we will take up, just see this picture, that how with the help of a mechanism or machine, a very heavy weight is being moved or lifted from one place to another place. So how this is working, what are the different principles that we are going to discuss today. Now see that this whole topics, that is kinematics and the dynamics of mechanism, is related to the theory of machines, and this is defined as the branch of engineering science which deals with the study of relative motion between the various parts of the machine. This picture is a just simple sketch of a machine having the different parts. Now these all parts have motion between them. So this is basically that what is the motion and how the motion of one part is affected by the motion of another part will be dealt in this subject. Now whenever we are taking the machine, then definitely we have to define what is the machine. Machine, if we say, it is a device which receives energy in some available form and utilize it to do some particular type of work. For example, this is an exercise machine where the human power is being utilized in rotating this wheel or the reciprocating motion of this wheel. So in this way, the energy from the human being is utilized or converted in the rotary motion of this wheel. Now if we divide the theory of machines in the different subjects from the point of view of study, that is, first is your kinematics, second is your dynamics, third is kinetics, and the fourth is statics. We will first take up different these subdivisions and what is their actual meaning. So if you see that, what is the kinematics? It is the branch of TOM which deals with the relative motion between the various machine parts. For example, we are taking this, so each part, relative motion between the parts is dealt in the kinematics. Second branch is the dynamics, which is a branch of theory of machines which deals with the forces and their effects while acting on a machine parts in the motion. Now see, this is a very simple mechanism, that this roller or the roller machine is the movement of this is only because the rotation of this wheel or the reciprocating motion of this connecting rod. So we have to see that what are the forces and their effect while they are acting on the machine part. while this is transmitting the forces on the connecting rod, this is transmitting the force on the this moving body. So this is dealt in the dynamics of machine. Third branch is the kinetics. It is basically the branch which deals with the inertia forces. Now inertia is basically a type of a property in which the body remains in the motion or body remains in the static position unless and until a force is applied. So these inertia forces are studied in this branch, kinetics, which arises from the combined effect of mass and the motion of the parts. The fourth branch is the statics. That is the branch of TOM which deals with the forces and their effects while the machine parts are at rest. The dynamics are when the parts are in motion, statics when the parts are in rest. The mass of the parts is assumed to be negligible. For example, we are taking this body and we are considering the effect of the forces on this body when it is in the rest. Now we come to the basic definition of the machine, that it is a basically device which receives energy and transform into some useful work. Why we said the useful work? Because there must be some usefulness of this work for the human being, and it consists of number of parts of the body. It is not necessary that there is only one part. It may be composed of different parts. That is the basic definition of machine. Now this is the small part which we have talked in my earlier slide, that is called the kinematic link or the element. How we will define each part of the machine which moves relative to some other part is known as kinematic link or the element. Means the link may be composed of many parts, but there should not be any relative motion between that parts of the particular link, but the link has definite certain motion with relative to other link. Now the link may be consist of several parts, just like this link has 2 parts, this link has 3 parts, but they don't have any relative motion between them. It will just bend like this and it will remain bent while it is working its natural work. Now if we take the example of different links, we all know the steam engine consists of a steam engine, piston, crosshead. So first it will have the one link as a steam engine, piston and the crosshead. This constitute one link. Similarly, connecting rod with big and small end brushes, caps and bolts constitute the second link. Crankshaft, flywheel form the third link. Similarly, cylinder, bed plate and the main bearing will constitute the fourth link. So the steam engine or the reciprocating engine is a 4-link mechanism. Now we will classify the different types of links. Suppose we have a singular link, a link which is connected to only one other link is called the singular link. Suppose this link is connected with this, so we will call that this is a singular link. Similarly, this link is connected with the 2 link. It can be connected into 2 link. So we will say that this is a binary link because it is connected with the 2 other links. Similarly, we have a ternary link in which this link is which is in a hashed shown by the hashed line. It can be connected into 3 links. So it is the ternary or tertiary type of a link. Quaternary link is a link which is connected to the 4 links, just like example 1, 2, 3, 4. So it is connected with the 4 links, so it is called as quaternary link. Now we will define what is the rigid body and the resistant body. A body is said to be rigid if under any action of forces it does not suffer any distortion or the distance between the 2 points on it remains same. It is very important. Suppose we have a one link, so the link can be rigid only when the two parts in the link, if you mark, they do not have any relative motion or they do not change their position while in the working position. Similarly, the second part, that is resistant body, are those which are rigid for the purpose which they have served. It is not necessary that resistant body for one purpose can remain resistant in the second purpose. A link which is defined need not to be rigid, but it must be a resistant body. What does it mean? That if we are using a link for a particular purpose, then it should not remain resistant for one purpose, but it will remain for another purpose. A body is said to be resistant body if it is capable of transmitting the required forces with the negligible deformation. It is called the negligible deformation, that is means the relative motion is zero. A link has two characteristics. First, it should have relative motion and it must be resistant body. For example, this is your cam mechanism, this is your slider crank mechanism, and this is your 4-bar mechanism. So all these three links have relative motion with each other. Similarly, the slider crank mechanism or the slider crank mechanism have their different links having the relative motion between them. Now the different examples of the link. For example, hydraulic press, jacks and brakes, in which the links are resistant to the compressive force, while in case of chain, belt and ropes, in which the links are resistant to the tensile forces. So this you should keep in your mind, that some are resistant to the compressive forces while some are resistant to the tensile forces. Now another important terms which comes in this course, that is the structure. It is basically an assemblage of the number of resistant bodies having no relative motion between them and meant for carrying loads having the straining action. If we say that this is the definition of a structure, then what is the difference between structure and the mechanism? That we will see in the later slide. For example, of structure is railway bridge, a roof truss or machine frame, which have the capability of transmitting the relative motion, but they do not have relative motion between them. Now we will see that what is the difference between the machine and a structure. The parts of a machine move relative to one another, whereas the members of a structure do not move relative to one another. This is the basic difference between the machine and a structure. Another important difference is that machine transform the available energy into some useful work, whereas structure do not transform any energy. It simply transmits the force from one end to another end. The link of a machine may transmit both power and motion, while the members of a structure transmit only forces. It cannot transfer the power or the motion. Now another important thing is that how to determine the degree of freedom. And basically, before go into detail for determining the degree of freedom, first we will see that what is the degree of freedom. Degree of freedom basically tells you that how many in which direction that particular link is free to move. It may be capable, or it may be able to move in a one direction, it may be able to move in two direction, it may be able to move in three direction. So if it is able to move in one direction, the degree of freedom is 1. If it is able to move in two direction, we can say that it is two freedom. So the Grubler gave the formula for calculating or determining the degree of freedom, that is 3L minus 2J minus 3J, where L is the number of links, J is the number of joints, and the G is the number of grounded links. Then we will also see that how we will determine the degree of freedom for different mechanisms. Now how we will simplify this Gruber equation. Since G is always 1, this simplifies the equation as degree of freedom 3L minus 1 minus 2J. So we will calculate the degree of freedom on the basis of this equation only. Now we will see that this is one of the example of a very simple mechanism having 9 links and 12 joints. So the degree of freedom will be 9 minus 1, that is into 3, 24, then again 2 into 12, 24. So degree of freedom of this mechanism or structure is 0. So there is no degree of freedom, it cannot move, there will be no movement. Now there are different types of motions. The first motion which comes is a completely constant motion. How we will define this completely constant motion? That sometimes the motion between a pair is limited to a definite direction, irrespective of the direction of the force applied. Such motion is completely constant motion. If we say that suppose we have a link, or we there is some type of a force, but the result of force applied does not create any effect on the direction of the movement of the part. That means the force applied in a one direction and the motion is in the another direction. So such type of motion is called the completely constant motion that you see in a different type of mechanism. Another is called the incompletely constant motion, where the motion take place in more than one direction. That is called the incompletely constant motion. Completely constant motion, you are applied force in one direction and the result is in another only one direction. While in case of incompletely constant motion, the motion can be in more than one direction. That is called the incompletely constant motion. Another type of motion is called the successfully constant motion, when the forming pair is like such that the motion is not completed by itself, but by completed by another mechanism which you are going to provide. That type of motion is called the successfully constant motion. So these are the three types of motion which you will read or study invariably throughout the course. Now we will come to the kinematic chain. What is kinematic chain? First we have studied the links. So basically the kinematic chain is basically an assembly of different types of links. When we join different types of links in a different manner, that becomes a kinematic chain. So in which the relative motion of the link is possible and the motion of each relative to other is definite. So the kinematic motion can be of the chain can be plane motion, can be rectilinear motion, or can be curvilinear motion. So we will first define that what is the plane motion. See this figure and we will first see that what does it say mean by the plane motion. The motion of a rigid body is said to be plane motion if all the points in the body stay in the same parallel plane. For example, this is in a reciprocating and this is in a oscillating mode. But this link and this link remain in this vertical plane. So we will say that the motion of this rigid body is in plane motion. A plane motion can be composed in the translation motion or rotation motion, as we have seen in the earlier case, that here the motion is your reciprocating motion, and this is in the rotation motion. So it can be translation, or it can be rotation, or it can be both. If we take the example of a rolling cylinder without slipping, then it is basically a rotation as well as translation. So the translation and the rotation can result in a plane motion if the rotation take place about the axis perpendicular to the plane of motion. Then we say that it is in the same plane. So we can say that both motions are taking place and both motions are plane motion. If we see that this example, this is a combined motion of translation and rotation. This your body is moving and also the rotating. So it is basically rotating as well as it is moving in the x direction. Similarly, you see that this mechanism, this is reciprocating, and on the basis of this, this rod is oscillating. So again, it is a combination of translation as well as rotation motion. Now we will come to the rotation of the rigid body. The rotational motion is characterized by the same angular displacement of all the points in the rigid body. It follows the angular displacement, angular velocity, angular acceleration at given instant. Now see that this is the trajectory of each point on the body, and it must be circular, then we can say that the motion is rotational motion. A rigid body is said to be in fixed rotation if there exists a fixed strength line within or outside the body such that the points identified with the body, but that line have zero velocity or zero acceleration, that in the case of your spinning wheel or spinning which you always play, that is your lattu, that at the bottom it has the angular acceleration or the angular velocity 0, where it is the tip touching the earth. The rotation may be specified to about the point basically. If there exists only a fixed point identified within the body where the both velocity and acceleration vanish. The example is the spinning top about the tip, or for axis the rotation. Another example is a shaft rotating in a fixed journal bearings. This motion is characterized by the angular displacement in radians, angular velocity, and the angular acceleration in the radian per second square. Now these are the various terms which you can study, just like angular displacement, that is defined in terms of theta, angular velocity, that is defined in the as omega, that is differentiation of theta with respect to time. Then angular acceleration is denoted by alpha. This is differentiation of omega with respect to time, or double integration and differentiation of theta with respect to time. Linear velocity you can define as v, it is ds by dt, or we can also combine it and it comes as v is equal to r omega in case of angular velocity. Similarly, linear acceleration can be defined as a, which is v r d square theta. D square theta is alpha. So the linear acceleration is the multiplication of radius and the angular acceleration. If you take the case of pure rolling motion of a cylinder, or a sphere, or axis or center moves with rectilinear as translation, whereas other points have motion which is combination of rectilinear or translation. The point of contact with the stationary surface has the zero velocity. Therefore, all the points in the cylinders rotate about this point at a particular instant. The magnitude of the linear velocity is proportional to the distance from the point of the zero velocity, that is the center point. And this is give you the example of a rolling, and all these velocities are perpendicular to the this axis. Now we will come to the planar mechanism, or what is the planar mechanism. A mechanism can be defined as a closed kinematic chain in which one link is fixed. The kinematic chain which forms a mechanism should have always a constant motion. It means a definite motion of a link produces the unique motion in other links. Similarly, the relative position of one link defines the relative position of any other point on the any other link. These are the example of planar mechanism. This is a 3-bar mechanism, and this is your 4-bar mechanism. Then we can take up the 3-link and the 3-pair kinematic pair, and if any of these 3 links are fixed, in case of 3-bar there is no relative motion, and therefore the 3-bar mechanism cannot be made as a basic mechanism, therefore we take 4-bar mechanism as a basic mechanism for studying the different mechanism. This is basically gives you a picture of a 4-bar mechanism, that is a reciprocating engine. This is a connecting rod. This is your crankshaft, and it is rotation. On the basis of this rotation, this connecting rod reciprocate or oscillate on the basis of which this piston reciprocate to and fro under the crossheads. In the internal combustion engine, it converts the reciprocating motion of the piston into the rotatory motion. This is your reciprocating motion, and on the basis of this we get the rotatory motion of the crankshaft. The mechanism is also used in the reciprocating compressor, in which it converts the rotating motion of the crank into the reciprocating motion, just opposite of this. In the internal combustion engine, the reciprocating motion is transformed in the rotary motion, while in case of rotatory compressor, the reciprocating rotary motion is transformed in the reciprocating motion. So these are the 2 examples of the 4-bar mechanism. Now we will come the different types of mechanism. First we will take up the 2-bar. Just see that this is a 2-bar, and it is of no use. Only the simple thing is that it is basically a structure. Similarly, 3-bar, again it has a 0 degree of freedom. There cannot be any movement between these links, so it cannot be considered as a mechanism. Similarly, the 4-bar mechanism has 1 degree of freedom. On the basis of movement of this, these 2 others are rotating or having motion, so therefore this degree of freedom is 1. So the 4-bar linkage is the simplest possible pin joint mechanism, having the single degree of freedom, and that 4-bar linkage is used for the basic study in the mechanical engineering. Now this is the we will first define the 4-bar nomenclature. Just like this is your grounded link, which are fixed, a grounded link you can say, or you can say the fixed link. This is your link 1, this is your link 2, this is link 3, and this is link 4. So one link is grounded or fixed. This can be your crank, then connecting rod, and this is your reciprocating. So any of this can be you can give any nomenclature depending upon the use. Now comes the inversion. We have a 4-bar mechanism, 1, 2, 3 and 4. Now you can say always we can fix this link, we can fix this link, we can fix this, or we can fix this link. Yes, you are right. because just by fixing one link you can have a different type of mechanism. For example, if you are fixing link 1 or link 2 or link 3 or link 4, then you get the different type of mechanism that is called the inversion of basic mechanism. So suppose we have a basic mechanism as a slider crank mechanism that can be converted into Oldham coupling, that can be converted into Scotch mechanism. So in this way only one mechanism can be converted into its different types of shapes or different types of forms. So only by fixing one different link we can get the different form of mechanism. Here we have four types of example in case of 4-bar mechanism. Since we have 4 links, so either you can fix first link, second link, third link or fourth link, and in either case you get the different type of mechanism. So this all topic will be taken in the later stage, but today we will first take up, just see that different type of mechanism. For example, this is your cycle wheel, this is your some type of a robot. This all comes and having the have the different type of mechanism for the formation. And this again you are very familiar with the motorcycle or this type of a your automatic guided vehicle. So all these or this is suspension mechanism which is in this one. So all these having the mechanism or different type of mechanism it has. Now the question comes that when the two links are joined together, what type is termed, or how we can term this linking of two elements or the kinematic chains. In a mechanism, bodies or links are connected such that each of them moves with respect to one another. So the behavior of the mechanism depend upon the nature of connection of the link and the type of relative motion between them. These connections are called the kinematic pair, and this kinematic pair is defined as a joint of two links having the relative motion between them. Another definition is that the two links or the elements of a machine when in contact with each other are said to form the pair. If the relative motion between them is completely or successfully constant, the pair is called the kinematic pair. Therefore, every pair cannot be termed as the kinematic pair, while all the kinematic pair can be termed as the pair. The pair can be said kinematic pair only when the motion is completely or successfully constant. Now there are 3 types of pair. First is your lower pair, higher pair or wrapping pair. In general you can define different pair just like sliding pair, turning pair, screw pair, spherical pair, lower pair, higher pair, self-closed pair or the forced closed pair. So we will take up each pair because this is the most important, that you are linking two elements and a different type of pair is formed. For example, first is called the lower pair. If the contact between two links is a surface contact, then there is a formation of lower pair. The example are the motion of slider in the cylinder or the motion between crank pin and the connecting rod. In this, under the category of lower pair, the first pair is called the revolute pair or the turning pair. Just see that this is the revolute pair or turning pair. This is fixed, so the motion is only rotation. There is no other motion. So this is a revolute pair. and having relative motion between the element 1 and 2. There is no other motion. So the revolute pair has a single degree of freedom. Second type of pair is called the prismatic pair or the sliding pair. Just see that this is a big block and this small block is sliding or reciprocate through the sliding motion. So again it has a 1 degree of freedom and it has a only sliding motion. So that is why it is called the sliding pair. This is called the screw pair. When this is rotating, and by rotation it is moving up and down, so it has a two motions related to each other, translation motion as well as rotation motion. In this screw pair, it has a 1 degree of freedom because the relative motion between 1 and 2 can be expressed by a single coordinate. This is your simple formula for calculating this, where L is the lead screw, that is the angle between two tangents, and this is the pitch, this is the lead of the screw. So these two coordinates are related by this formula. That is why this is called the having the single degree of freedom. Now another pair is called the cylindrical pair. As you see that this is the motion, and again there is a rotation, reciprocation. So the rotation as a translation parallel to the axis between element 1 and the element 2. Since the relative motion is expressed by two independent coordinate theta and s, therefore the degree of freedom is 2. They cannot be related with each other. Another pair is called the spherical pair, a ball and the socket joint. Any rotation of relative element 2, that is element 2 with relative to element 1 can be resolved in the 3 component, just like see either on the x-axis, y-axis or z-axis. So out of these 3 coordinates, alpha and beta are required to specify the position of axis OA, while the third coordinate theta describe the rotation about the axis. Therefore it has 3 degree of freedom. Another pair is called the planar pair. Planar pair is shown just like this, having the relative motion between 1 and 2, and it can be defined on the axis x and y. Then again it has a 3 degree of freedom because 3 type of coordinates are needed to define the motion between these two bodies. Now we have studied the lower pair, then comes the higher pair. Higher pair is that type of pair which has a point contact between two links. For example, we have a cam and follower mechanism where there is a just point contact between the follower and the cam. So such type of joint or the pair is called the higher pair. This contact between the cam and the flat faced follower is through a line or the point. Another examples are ball bearings, roller bearing and the gears. All they have the point contact or the line contact. Similarly, a cylinder rolling on a flat surface always has a line contact. Therefore it is a higher pair. Third category of pair is the wrapping pair. Wrapping pair comprise the belts, just like you see these are the chains. Belt comes from one side of the pulley and goes to the another side, that is called the wrapping pair. Now we will come that you have studied the different type of pair, you have studied the different type of mechanism, just like a 4-bar mechanism. Then a question comes to your mind that what is the difference between the machine and the mechanism. Both on one hand they seems to be similar, but we have tried to differentiate between the machine and the mechanism. So if we say that what is machine? Machine is a simple system which is used for transforming the mechanical energy into some other useful type of energy. While mechanism, the objective is to only transform the motion without considering the force. That is the mechanism. Another difference is that every machine has to transmit the motion, because the mechanical work is associated with the motion and thus makes the use of mechanism, while the mechanism is concerned with the transfer of motion only. Another important difference is that machine can use one or more than one mechanism to perform the desired function of the machine, while it is not true with the mechanism. Mechanism has only always one system to transform or transfer the motion. Now these are the different types of machines. For example, this is your power system. I have just showing you so that you have interest in this subject, because just like this is a trajectory control having 2 degrees of freedom for the actuation and 3 degrees of freedom is required for calculation. So all these are linked with the kinematics of mechanism or the dynamics of mechanism or the theory of machines. This is a micro actuator, again having the some type of ratchet assembly or some type of thermal actuator or pin joint. These all having the basic terms, that is called the 4-bar mechanism or 6-bar mechanism, and it is very interesting to study this course because you directly find the application in these different areas. Similarly, you find again the application in the area of biomechanism, where you find that here the manufacturer believes that more thrust can be delivered to the kick, and this can be the having again the basic principle of theory of machines. Now comes the mobile machinery. Again we take the different principles of mechanism, and we find here it's very useful. These are the some other examples of theory of machines. In the today's lecture you have studied that kinematics of machines or mechanism deals with the analysis and the synthesis of mechanism. In this analysis you have found that the basic element is the link or element. We have defined the link as a basic element which do not have relative motion and a resistant body. A resistant body is a rigid body for its own purpose. The rigid body is that body which do not have relative motion between them. So similarly we have also studied that how to calculate the degree of freedom. Degree of freedom means the different way or how you the one element or the kinematic chain is free to have the motion. It may be 1 degree of freedom, it may be 2 degree of freedom, it may be multi-degree of freedom also. The basic chain or the mechanism which we have studied, that is the 4-bar mechanism, and by fixing or grounding any link we can find the different types of mechanism. So today's in the lecture we have studied the unit 1 and unit 2 of this course, and we will take up the other sections in our next coming. Thank you.